Look at the first one. We are going to find the exact value of the definite integral. It's called a definite integral because you have numbers here, and these numbers are called the limits of integration. Okay, so we can find an exact value for this definite integral with this function in here. So what I first want you to do is ignore the limits of integration, right? Think back that we're in December, and let's try to take the antiderivative of 12x plus 9. So I actually did the notation where I did a capital letter F, right? So the idea is that if I take the derivative of the capital letter F, that would be the same as our f of x function, which is the one that's in our integral. Okay, so f of x, when it's capitalized, is the antiderivative. So I see 12x to what power? The first power. So when I do the antiderivative, I have to put it to the second power. So what number times 2, right? Because when I take the derivative, I'm going to move this 2 in front, would give me 12? 6. So this is something we practiced at the end of last semester. Right? If I took the derivative of 6x squared, do I get 12x to the first power? Yes, so you can always check. Okay. Now, what is the antiderivative when you have a constant? 9x. Very good. Right. Remember, the derivative of a constant is 0. But going backwards, right, the antiderivative, we need to put the constant number with the x to the first power. All right. Now, don't write this. Okay. Don't write this. I mean, write that. But don't write what I'm about to write. I had you guys put something after this. You remember what we put after this? Very good. Plus C. Don't write this. Don't write it. Don't write it. Don't write it. Okay? So don't write plus C. All right? And remember, C stands for any constant, because it could be plus 7, it could be minus 11. It doesn't matter, because when you take the derivative of that constant, you get 0, right? And it's not there. So when you do the fundamental theorem of calculus part 2, you get to pick what you want C to be. And you should always pick 0. What's the derivative of 0? Exactly. All right? It does matter. I mean, no, it doesn't. But if you don't pick 0, you'll have to do more work. So always pick 0. You could pick, if you want to go crazy, pick plus 1. Put plus 1. But when I do my algebra, you'll have to have those plus 1s in there. So that's why I would choose 0. Sure, but don't do it. Okay. Yeah, it'd just be more complicated for no reason. It doesn't, though. It doesn't change the answer for the value of the integral. It makes your life harder. All right? So here's how I want you to write it. So copy it down. Put it in parentheses. Put a vertical bar after it. See that vertical bar? Put a vertical bar, and then I want you to put 1 and 3. So by putting this notation, you're telling the person reading your work that you have found the antiderivative, and you're about to evaluate it at 3 and at 1 and find the difference of those. All right? So we tell them we're going to do this. What? Is there a question? Okay. He's just saying it. No worries. All right, so let's plug it in. So I have times 3 squared plus 9 times 3 minus 6 times 1 squared plus 9 times 1. Yes, I need it. So the fundamental theorem of calculus part 2 says if we find the difference of these, right here, if we find the difference, wait for it, it's going to be HD in a moment. There it is. The difference is what we're doing. Always subtraction. Now, you might end up, Anita, it's going to happen, where you might end up subtracting a negative. So then obviously you're going to end up adding, but we always use subtraction between these values. Okay, so let's do our algebra here. 3 squared, 9. 9 times 6, 54, plus 9 times 3, 27. Okay, cool. 1 squared is 1. 1 times 6 is 6. 1 times 9 is 9. I think I heard 81. And then 6 plus 9, 15. When you subtract, you get 66. So the value for the area under the curve. Oh, I missed the joke. I don't know because I was too busy teaching. Okay. So the value for this definite integral is 66 units. Questions on number 1? You don't need it. Questions? Correct. I'm going to do some, because I know you like this, David. I like it too. When we get to 3 and 4, I'm going to do some visualization to help you with it. So hopefully kind of link it to what we've done the last few weeks. Let's do number 2. Number 2. It's another definite integral. I see my limits of integration are going from 2 to 4. Let's find the antiderivative of negative 4x. So I'm going to put x squared. All right, so what does the number in front need to be so that when I take the derivative of this, I get negative 4x? Negative 2x squared would be correct. Okay, and then what am I going to put after this? Minus 8x. Again, you could choose plus a million like Anita said, right? I wouldn't. I would choose plus 0 every time. Yes. Okay.
So then what's the point?
Guile actually raised his hand. Can I go with Guile first?
So like if we're finding an antiderivative, would we have to add to it since like it's already negative? Right? Because like if we're finding the antiderivative, don't we have to add 1 to it?
Add 1 in the power. Is that what you're saying? Yeah, we added 1 in the power, but the sign is subtraction. So when I take the derivative of negative 8x, I need it to be negative 8. So those are different things. Okay, David.
So then what's the point of there being plus c or like plus any number?
So when I taught you antiderivatives, they were indefinite integrals, right? It was this symbol with no limits of integration. So since you can't find a value, you put plus c because it could be any number of infinite functions that would work, right? But now that we have limits of integration, right? We have numbers here. We can actually choose a value for c, and you should always choose 0.
So the number should have to be between the right?
One more time?
No.
Number?
No. Okay, so I'm choosing 0 for my plus c, putting my bar, and I'm evaluating at 4 and at 2, and I'm finding the difference between those. So I'm going to plug in first, negative 2 times 4 squared minus 8 times 4 minus negative 2 times 2 squared minus 8 times 2. Okay, 4 squared is 16. 16 times negative 2 is negative 32. Minus 32 minus 2 squared is 4. 4 times negative 2 is negative 8 minus 16. Now this is actually not 0, right? Negative 32 minus 32 is negative 64. And then we're subtracting. What's a negative 8 minus 16? Negative 24. So this is what I mentioned earlier, Anita. We're always going to do subtraction, but on this one, bless you, I end up subtracting a negative, so I am technically going to be doing plus you. That's like a record, plus 24 to get negative 40. Yeah, question. Go ahead, everyone. Ooh, great question. Are you talking about the limits of integration? Yeah, I'm pretty sure on this link, all of the limits of integration are going to go from least to greatest. But yeah, you're always on the lookout for if this had said from 4 to 2, I would have flipped it and then done a negative out here. So at the very end, I would have done the opposite of this. So just 40. So I don't think it's it's definitely not nothing, but it's not as big a deal as you think because it's just do everything the same, but then at the end, do the opposite. Okay, let's do 3. Let's do 3. Here we go. We have the integral from 2 to 6 of negative 3 dx. So what's my antiderivative for negative 3? Negative 3x. Do I have anything else? No, right? You could do plus 6 or minus 8, whatever you want, but I'm going to choose plus 0 as my c. So I'm evaluating this at, at 6 and at 2 and subtracting the difference. Now, I'll be honest with you, once I finish this, I actually don't show any of this work. I do it with a sketch. So we have negative 3 times 6 minus negative 3 times 2. So that's negative 18 minus negative 6. Again, that becomes addition to give us negative 12. So if I get this question on this link or on the AP exam, I don't actually show any of this work. What I do is I sketch it. We're going from 2 to 6, right? And what's my function that's after the integral symbol? Negative 3. How does it look when you graph y equals negative 3? It's, don't need to say straight line, right? If you say lines mean straight. It's a horizontal line, right? So I'm just trying to find the area under the curve here, what shape is that? It's a rectangle, right? So this distance is 4. This is negative 3. What is 4 times negative 3? Negative 12. We did. I'm trying to connect it in your brain, George. Right. One is using the fundamental theorem of calculus part 2, and then one is using your understanding of how to graph a horizontal line.
Wait, why?
Correct. And I tell you, if I see this, I do the graphic. Specifically, what would you like for me to go over again? The very end? Well, so the integral said from 2 to 6, and it said my function was negative 3, right? So I drew Alan a line at negative 3, and the area under that curve is the shape of a rectangle, right? So this area right here. So to find that area, I did length times width. So 4 times negative 3.
Oh, that's what we did last time.
Are there any questions? Any questions on number 3?
What's your favorite little kids?
Wait, I have a question though. What's the difference from this and what we did before? She just said.
I'm trying to answer it a different way because clearly the last time I answered it, it didn't work. What I said last time was the way I'm teaching you now, my students last year was like, this feels a lot more like algebra-like with like all of the fundamental theorem of calculus part 2. The difference is that's what you're doing today. What I had you guys kind of doing the last week or so is doing this kind of stuff, more like graphing, shading, looking at graphs to find the area under curves. So this feels less graphing and more.
Can we technically graph?
Absolutely, Georgie. I'm gonna do it for this one. Can we do it together on this one? It's like when I'm making lesson plans and be like, this is for Georgie. She doesn't know it, but this is for Georgie. Okay, here we go. Let's do it the way that I'm trying to teach you, right? Because you do need to know how to do it the way I'm teaching you. So I'm going to do the antiderivative of negative 2x. So I'm going to write x squared. Okay, and what has to go in front? A negative sign, right? Because 2 times this negative 1 gives me negative 2. Remember, if you're ever like, I wonder if this is right, always take the derivative and see if it matches. Plus 5x. Draw the bar and do 3 and 2. So let's do f of 3 minus f of 2. So I have the opposite of 3 squared plus 5 times 3 minus the opposite of 2 squared plus 5 times 2. What's wrong? This guy, Giles just got the, he's got the music in him right now. I've got the magic. That's you right now. Every time I touch that. No? You don't know that song?
Have you seen that? Have you heard that one song?
That one song. I have, yeah. All right, what's the... Sorry, Al, that was me. I'm sorry, Al. Only a little bit. I was watching a video, Alan, the other day for stats, like prepare, and I yelled at a student, and guess who I yelled at? Your brother. Okay. -9 plus 15 is 6. -4 plus 10 is positive 6? Subtract, and you get 0. All right, this is the fun one. Can I show you? This is exciting. Oh, where am I going? It's exciting. Ready? Let's see. What? Like a button? We eat different potatoes. Okay. Is it negative 2x plus 5? Was it negative 2x plus 5?
Yeah.
Thank you. And it was 2 to 3, right?
Yeah.
All right. Are you excited, Georgie? I know you're excited. You're not excited? Okay. To help your brain see it, let me do this real quick. So here's what we just found. We just found the area under the curve from 2 to 3. So it'd be this triangle, which is going to be a positive area of 1/4. But then look at this triangle. So it is literally symmetrical, but it's below the x-axis. So the area here is -1/4. So when you add those together, you get 0, which matches what we got. Oh my gosh, it's amazing. Which one? The one before or 1 or 2? Number 2, you're going to have to read it off for me. -4x plus 8 and minus 8. And what are the limits of integration? 2 to 4? Okay, what was the answer? Okay, so what was it? X equals 2 and x equals 4. So it's a trapezoid, right? You can do a trapezoid here. So the distance from 2 to 4, that's going to be our height. Base 1. You guys want, that'll be done, just the last one. Base 1 is -16. So do -16 plus base 2, which is -24. What's -16 plus -24? It is -40. Okay, what's that divided by 2? What's half of that? -20. And then it says to multiply by our height, which is this. So -20 times 2 is -40. Gosh. What did Father Gibbons say today?